Welcome to the LP360 tutorial on Model Keypoints. Model Keypoints is a new capability that we've added to the advanced edition of LP360. The general purpose in Model Keypoints is to reduce the number of points in a ground model typically to the minimum number to meet some accuracy requirement. In my example, I've got a typical project area that's already been classified in terms of ground, which we see in orange in the profile view, and some other objects. And I notice I've not done a good job of classification. I've got some vegetation in my buildings and so forth, but what I'm really interested in is the ground class. And you'll notice that the point density in this ground class is rather high, and if I'm going to export my ground class data to an application that doesn't handle bulk points so well, I might want to thin that down, but I can't just thin the points because the number of points needed depends on the shape of the terrain. So for example, in these flat areas, if you see my cursor moving along here on the left, I don't need so many points. It's quite flat. A point every 100, 200 feet would be fine. Whereas when I get some curvature, I'm going to need more points to accurately represent that surface. And that's the entire purpose of the Model Keypoints algorithm. It shows up as a new point cloud task. So I'll switch over to my point cloud tasks tab. Point cloud tasks, add task. And in the drop down list, you'll notice the new filter called Model Keypoints. I'll give this a name, perhaps my MKP for my Model Keypoints. That's now selected, and you'll notice the set of parameters for this particular filter. So the first thing I need to do, as in most filters in LP360 Advanced, is select the source points that will be candidates for whatever operation we're going to consider. In this case, I only want to consider the ground class. I'll turn off selection on all points, and I'll select my ground class, class 2. And I'll quickly check to make sure that I'm going to include all returns. I'm not filtering on elevation range, nor am I filtering on intensity. OK from that dialog. Now the next operation is, what would I like to do when I've done my algorithm and I've decided the points I really need to keep based on some criteria that we'll talk about in just a moment. And what I'm going to do is say, move those points to the class Model Keypoints. And this is a standard ASPRS LAS class, so it'll be in your drop-down list of selectable tasks. You can also optionally set a Model Keypoints flag. We're not going to do this in this particular demonstration. Now I know that the units of this project are feet, so I'll go down to the bottom of the screen and set my project units to feet. And I think I'll go ahead and continue to use meters in my filter, just to demonstrate this capability in LP360. The sample distance says, what is the maximum distance you would like between points in this reduced model? There are some applications that may want to have a minimum number of points so that they can reduce the triangle edges, for example, when they ingest the model that you're going to create. So let's just say that we want 10 meters. Now, since my project units are actually in feet, this is a state plane project, and I've specified units in meters, my filter will automatically convert the 10 meters into the requisite number of feet, approximately 30 in this case. Now, the deviations specify how accurately you would like the model. So as I move over this terrain, what is the error tolerance I'm willing to accept? So in our case, we'll say let's really say we're in meters. Let's say 0.25 meters above and 0.25 meters below. And this means that the model that we create will deviate from the ground surface by no more than 0.25 meters above the surface and 0.25 meters below the surface. And finally, we'll hit the apply, something I frequently forget to do on our point cloud tasks, and we're ready to run this filter. However, I'd like to be able to instantly view the results of this, so I need to do a little bit of setup in our symbology. So in the top toolbar, I'll select our active LAS layer properties. I will click on symbology, and I want to add a value to the symbol table under classification. And we want to add Model Keypoints and say OK. And I'm not crazy about the default symbology on the model key points, so I'll double click that and say I want this to be sort of a pink color so it'll really stand out, and I'll fatten it up a bit and say OK to that. Apply these changes, and I'll also want that to occur in the profile view, so I'll need to copy those settings over to the profile view. So I open the Copy Legends dialog, and I'll say copy from the LAS layer to the viewer window, which is the 3D window, and also to the profile window. I hold the control key down to multi-select. Say OK. I should be good to go. Now I'm just going to drag an area, and we'll see what happens with model key points. So from my task toolbar, I'll select rectangle, and we'll just drag a rectangle through this area. And you'll notice the processing information that we have in the lower left panel of our key, processing block 1 of 6, running iterations, and so forth. So this will take a little bit to process as we calculate what points are really needed to give us a good surface model with respect to the ground. So again, in the curved areas we'll need quite a bit, and in the flat areas we'll have a low point density, and we'll see that occur in just a moment. So our model key point extraction has completed. Then we zoom in on the profile a bit, then you'll see in the flat areas where I have a purple point, which these are or a pink point, these are the model key points, and we see them stretching along some distance apart in the flat areas. And then we get into an area of curvature, a little bumpiness in the terrain, then we see a higher densities so that we can have an accurate model of our terrain surface. That's really all there is to the model key points. Now these would be used typically in either directly exporting data or in visualizing a tin surface. So for example, I could add a new filter, add filter for display, I'll call it MKP. For model key points, I'll edit this filter by removing all the existing classes and select only the model key points and say OK to that. X that off, and now I can select it from my drop-down list of filters. And there are the points that were selected to do this three-dimensional modeling. I can display this in a tin view, and here I have a tin constructed only of the model key points versus the tin that I might see constructed of the ground surface with all the features modeled by intensity. And the last place you would use this, of course, would be exporting LiDAR data. I would move through my filter and I would disable all points except model key points. And then when I say exported a grid, it would pick up the model key points to do this more rarefied display. So that's an overview of our model key points feature. Thank you for sitting in on this demonstration.